Right. Good afternoon, everyone. Hope everyone had a good lunch. My name is Joost Peters. I am the UI and UX designer at Forcefield, and I'm here to talk to you about how we designed the heads-up display for our third-person VR game. So a little bit of history about Forcefield before I get started. We are a VR and AR exclusive game development studio in Amsterdam, in the Netherlands. We merged with Vanguard Games, and our team is about 70 people right now. I used to work at Vanguard Games before we merged. You may know Vanguard Games from titles like Greed Corp, which is a top-down strategy game, Gatling Gears, which is a top-down twin-stick shooter, Halo Spartan Assault, which is a top-down twin-stick shooter in the Halo universe, and Halo Spartan Strike, which is a top-down twin-stick shooter in the Halo universe that was a sequel to the first game, Spartan Assault. So when we got started on making our first VR game, it should come as no surprise that it was a third-person, top-down twin-stick shooter. So the idea was, what can we do if we take what we learned from all those games and take it into VR? And the result is called Landfall. Our game was announced a couple weeks ago at Oculus Connect 3, and because it's not out yet, I brought a trailer.
After the drowning, a vast ocean covered the earth. But the survivors united to reclaim what land they could. Newfound wealth awakened envy and greed. Now civil war threatens to tear humanity apart once again.
So this is Landfall. It's our first VR game. Again, the title of the presentation gave it away, but it's a top-down, third-person twin-stick shooter. You control the soldier on a diorama-style battlefield. You can summon giant mechs. We call them striders to crush your enemies. And we have several different equipment packages that have different weapons and different striders in them. The game contains a single-player campaign, a co-op campaign, and multiplayer missions. And in co-op and multiplayer, we even show your opponents and your teammates' heads floating in VR, which is really cool, so you can see who you're playing against. So what I'm going to be talking about today is how we designed the heads-up display for the game. I'm going to show you the challenges we ran into when we started on making a VR third-person game. Then I'm going to explain some of the rules that we set for our HUD when we started development. I'm going to show you some practical examples of how we solved some problems and some challenges that we had. Then I'm going to show you how we updated our rules, because we found that some of the rules we set in the beginning didn't work throughout the entire development. And then I'm going to summarize everything to tell you the lessons that we've learned from this project. All of the images and videos in this presentation are, of course, in 2D. It's very hard to explain why something doesn't work in VR by showing it in 2D on a projection screen. So you're going to have to take my word for some of these things. So some of these challenges that we ran into may be no-brainers. They may sound very obvious, but we had never thought of these things before we started developing a VR video game. First problem we ran into is there is no screen. What do I mean by that? Well, if you look at a traditional HUD, this is the HUD for Halo Spartan Strike, you can see that it is projected onto the screen, it is drawn over everything, and it is attached to the screen corners. Of course, this doesn't work in VR, because on a traditional screen you have a fixed viewing rectangle, you have screen corners to attach everything to, and the player is always looking at that fixed viewing rectangle, so you always know that they're facing the screen. In VR, no fixed viewing rectangle, no screen corners, and your player can look around in 360 degrees, and you know where they're looking, but they might not be looking where you want them to look. So that presented a huge challenge. Second problem we ran into was that you can't just attach a bunch of UI to the camera. It just doesn't work, it's very uncomfortable. So let's go back to Spartan Strike, and let's say that you wanted to take this game and port it into VR directly by reusing everything we had. As I said, there's no screen corner, so you cannot do what's on the screen right now. But I guess you can take all the UI and slap it on a plane and attach it to the camera. So I did that as a test. And this is terrible. You can see the biggest circle is what you can focus on. Pretty much everything outside it is your peripheral vision that you cannot focus on. You cannot read anything in there. The center circle is the comfortable area of your vision that you can really focus on things in. And as you can see, if you just slap this UI on a plane, it blocks everything. When you try to read something that's just outside your center of vision, you tend to move your head instinctively to look at something. And instead of being able to read it, you push it away. So we call that the push effect. And obviously that doesn't work. This is a stupid example that I made for this presentation, but don't do this. The third problem that we ran into is that every element you make for UI or heads-up displays in VR has to exist in 3D space. There's no way around that. So let's say that you have an objective marker in the level. The objective marker is placed in 3D. It's behind this APC. And this is a pretty normal situation. And in any traditional game, you would just take this objective marker and draw it over everything. So you can see objective, no matter if it's behind a car, a wall, a mountain, or the entire level. But if you shift your perspective in VR, now the tree is in front of the objective marker, but the objective marker is still shown over it. So the draw order for this objective marker is completely wrong and unnatural, and it doesn't make any sense. So you get conflicting data, and it's very uncomfortable. If you haven't tried this and you're working on a game, I highly recommend that you try this to see how bad it is. So we came up with a set of rules after we did research and pre-production, and we tried to stick to these rules throughout the entire development of the game. So the rules were: position UI elements where the player needs them. If we cannot position them directly in their field of view, we need to guide their gaze towards where we need their focus to be. We will not draw UI over everything, and we will not attach UI to the camera. And these are the rules that we started development with. So now I'm going to show you a couple practical solutions about how we solved some of the problems. We found all of these solutions by iterating constantly during development and trying everything we could come up with until we found a proper solution. So we found out that we needed to guide the player's gaze to wherever it needed to be, as I said. So players tended to lose track of where they died and where they respawned, because these two locations can be different all the time. So the solution we came up with is to just draw a straight line from the position where you die to the position where you're going to respawn, which looks like this. So you can see the player, middle of the screen here, is about to die, and then we draw a line that leads directly to your respawn location, and then after a couple seconds, that's where he appears. And this works wherever you are in the level, and it's also really effective if you die in a massive explosion and you can't see where your body is.
Explosives planted.
Another problem we had was we had a menu to switch weapons, which, as I've explained, has to exist in 3D space, so we have to put it somewhere in the level. But players would activate the menu, and it would just pop up in the world, and they wouldn't know where it was. So the solution we came up with is to use animation to guide the menu from where it spawns to where it needs to be, and then once you're done using it, it goes back again. So this looks like this. Player activates the menu. You can see it animates to its new location, and then once you're done using it, it animates back. So you can follow it with your gaze. And this also works wherever you are in the level. It always moves to a location in front of you, and then once you're done, it animates back. Okay, so we needed HUD elements in 3D space. We needed objective markers. You always need objective markers in games like this. So we knew we couldn't draw them over everything. They had to exist in 3D space, and they had to be able to be occluded by geometry. So the solution we came up with was we attach them to the pivot of the object that they're supposed to be on, but we gave them an offset from the pivot. And this lets them, when we face it towards the player camera, it lets us rotate it like it's on a swivel arm. So that looks like this. No matter where you're looking from, if you change the camera, it always faces towards you.
Run out of reinforcements. Command your troops to victory.
And then in practice, you can run up to it. You can get behind it, but I can still see myself. You can get in front of it, but I'm not occluding the entire objective marker. And that's also why we made it so big. We also figured out pretty quickly that if we were going to have UI elements in 3D space, that we were going to have to scale them. Because if you don't scale them, they get really tiny. So this is what happens when you don't scale the UI. So here you can see the player. He has a name, he has a health bar, he has a couple of other things attached to him. And it's going to run to the back of the level now. And you can see the UI is pretty tiny. And once he gets back there, it's pretty much unreadable. And I scaled it up for the video even. So we figured out this doesn't work. So what we did was we scale it based on the distance from the camera. But we don't scale it one-to-one because we wanted to maintain the illusion of you moving into 3D space. But once you get to the back of the level now, it's still completely readable. And we do this to pretty much every element that exists in 3D. So I was very adamant about not drawing UI over everything, but I had to admit defeat in that it didn't quite work. We figured out that we were going to have to draw some UI over everything. So we have in the game a VR aiming reticle, which is a UI element that you can use with your gaze to summon a strider. It looks like this. So you move it by just looking at the ground where you want to summon your strider, and then once it goes under a rock, it's gone. You can't see it anymore. So that means the UI element doesn't work because the feedback is gone, and this wasn't good enough for us. So we needed to come up with a solution. So the solution we came up with was split it into two objects. First object is exactly the same as the one you just saw. It gets hidden by any geometry that it goes under. The second object is also the same element, but instead of it being hidden by geometry, we draw it over everything, but it's semi-transparent. And when it's semi-transparent, it's not such a problem if you draw it over everything. So then it looks like this. Still move it, and when it goes under a rock, I can see the semi-transparent version, and I still have the feedback that I need. Other than that, it works exactly the same. And then you can summon your strider, and you can blow someone up by dropping a giant mech on his head. We also figured out we're going to have to attach some UI to the camera. We couldn't get around it for the entire game. One of the problems we kept having was players would lose their character. So you're playing the game, there's explosions everywhere, there's planes flying in, there's people screaming at you, there's people shooting at you from everywhere. So people are looking around at all the cool stuff we put in the game, which is great. We want them to do that. But then once they're done looking around, they can't find where their character is. So we made a locator that always points towards your player character, which looks like this. So this is always attached to the camera. It always points to where your player is. And as long as you follow it with your gaze, you always end up at your player character. And this also works no matter where you are in the level, whether you're in the front or in the back. We also have first-person aiming. You can take your strider and you can turn it into a turret, and then it goes into first-person perspective, which looks like this.
Charged and ready.
So now we attach a reticle to the center of the vision, because of course you have to aim, and this is the best way to show where you're aiming in first person. So this worked really well, and we needed this element to be attached to the camera. So in the end, after about most of the development, we changed our rules. The first two rules remained the same, but we changed the draw UI over everything rule, don't draw UI over everything rule to draw UI over everything as little as possible, and if necessary, use very small or transparent UI for this. We also changed the don't attach UI to the camera rule to do not attach large UI to the camera, don't block the player's view, and don't make people read outside of their center of vision because they'll do the push thing. We also figured out that diegetic UI, which is UI placed in the level or on objects, like the back of the like the health on the back of the character in Dead Space, that's better for VR because it means you need less UI and it's more natural for the player to read it. So the lessons we've learned: any UI you make in VR is much more demanding to make than UI in traditional games. You're dealing with so many variables that you need to keep track of everything. You need to keep track of where the player's looking, are they paying attention, are we drawing things over everything, are we hiding things behind objects? It's way more complicated. Second thing we learned is you can't rely on old solutions. I think every designer, programmer, and artist in the games industry has a bag of tricks that they like to use, and once you start working in VR, that bag of tricks goes out the windows because it doesn't work anymore. So you need to treat every problem that you find as a VR problem first and a UI problem second. And then you need to start building a new bag of tricks. It's the wild, wild west out there, as my friend Big Willie here will attest to. So when we got started, there was not a lot of stuff to look at. The DK2 had just come out. The best resource that we had was Oculus Share, which was great. A lot of people were posting experiments there, early prototypes. That was great to see stuff that worked, stuff that didn't work, being able to test stuff. Thankfully, we also had a great relationship with Oculus. Oculus showed us some games that were in development for VR that hadn't come out yet. We got an early look at AirMech, we got an early look at Eve Valkyrie, which was great. We could see what other people was doing and get inspiration from that. This was a great help, and it really helped kickstart our development. We also figured out, as I said before, people are completely overwhelmed and wowed by VR, especially if it's their first VR game. We did this to ourselves by putting in a lot of explosions and airplanes and gunfire and everything. But you really have to keep track of that as a UI designer or any game designer, because, as I said before, people might not be paying attention to the part of the game that you want them to pay attention to. And you need to figure out a way to either work around that or shift their attention to where it needs to be. Final note that I want to end on is, it is very awesome and rewarding to make VR games because of this. It was great to challenge a UI problem and see it work in a playtest and see people enjoy the game. It's also great as a VR developer to be part of the emerging VR development community. At Force Field, we believe that sharing these findings and doing these talks will help make the entire VR community better. So I would really ask all VR developers to do the same thing, and let's build a new design language for VR or VR UI together. So we have time for some questions. If you see me walking around the show floor and you have more questions, please don't hesitate to come up to me. There's a microphone in the middle if you want to ask a question. Hi.
Can you hear me? Yep, okay,
Yeah.
great. My name's Aaron. I'm working at Intel. My thought is more of a theoretical thought on your design process. Mm-hmm. If you were to take your game concept and make it work with the Oculus Touch, in terms of movement. Like you have the 2 sticks, so that would work, but all the other UI elements and how casting, you would cast like sight for, say, dropping your strider. Do you have any thoughts on that?
We haven't thought about the touch controllers in this project yet. When we started, they weren't available yet, so we had to use the gamepad controller. So we were, I wouldn't say we were stuck with that, but that's what we chose and that's what we worked with from the beginning. It would be interesting to take the touch controllers and see how we could work them into the game. I think maybe that's something we'll be able to do at a later date, but not for this version.
Thinking more theoretical, like how would you imagine it to be about the same as with your current UI experience in VR?
Right, so the question is, would the UI experience be the same? I think largely it would, because you need all the UI for the primary gameplay, so the health and how many grenades you have, and if your strider can be summoned, you need that on the battlefield, so I don't think that would change. With touch controllers, it is easier that you can attach UI to the actual physical hands of the player, so it would be easier to get their attention to something that's attached to their hands, because they will most likely always be looking at their hands somewhere in their peripheral vision. So that would really help.
I was curious, have you noticed any major differences in playtesting for players who are either, I think there's kind of 2 different subcategories. You have players who are used to twin stick shooters and players who are not. And you have players who are used to VR and players who are not. Have you noticed anything major among those groups in your A/B testing when you were working on these new designs?
Yeah, so definitely there are huge differences in that. People who are used to twin stick shooters and who are used to holding a gamepad, who know where all the buttons are, they pick everything up way quicker, and it's way easier to get their attention focused on something that they need to be focused on. New players who've never used VR or have never held a gamepad controller, it's way more troubling to get that to work. It's not impossible, but it's a lot trickier. So did you make any accommodations for the second group? Yeah, we did place there's a controller directly below your vision at all times. So if you want to know what the control is for shooting or what the control is for using your ability, you can always look down and there's a controller right below your vision at all times. But if you're just playing the game regularly, you don't see that because it's down here.
Hi.
Hi.
I don't know if you have any actual kind of camera movement in the game, or zooming in and out or anything like that you've had to deal with?
No, it's all fixed, which really helped us. It also helped with the problem that I showed with the objective marker being drawn over a tree, as we asked our level designers to keep a geometry like that away from objectives as much as possible. But from the get-go, we knew there wasn't going to be any camera movement, so we didn't have to deal with that. We always knew that the perspective would be fixed. Even in multiplayer, the 2 players on the same side are actually in the same position. They don't know it by looking at each other, but they are in the same exact position.
I had exactly the same question, was basically, did you deal with camera when you were designing UI? But it sounds like you didn't have to worry about it too much.
No, everything fixed camera positions. All right, no more questions? Thank you for coming to my presentation.